Hi everyone, in this video I would like to show you in details the entire process of my work on the interactive home renovation project in the state of Texas. I will show you all stages of work from start to finish and what problems I encountered and how I solved them. If you want to create the projects like this, I want to recommend you my course, which will guide you through all the steps of creating an interactive project in Unreal Engine. Link in the description. Let's start at the very beginning. At the first stage of work, I use 3D scanning with the Polycam app to get 3D model of house. First, I scan the facade and each of the rooms. Then the backyard and terrain. It was especially important for me to get a terrain model, as it has a strong elevation difference. For me, this is a good tool for getting raw material to start working on an architectural concept. This is what the scan results looks like after being imported into 3ds Max. Scans of the interior looks very well. I was concerned about the accuracy of the scan. I compared the dimensions on the 3D model with the control measurements and was pleasantly surprised by the accuracy. As for scanning the land, it didn't work out so well here, but I can work with it. Especially useful for me was the slope of the land, the boundaries of the structures and the position of the trees. Then, based on this, I built a 3D model with a new design. I merged all the walls of the house and decor elements into a single mesh to reduce the number of draw calls. Later I will explain it with an example. I want to say that it was not the best decision and I will tell you why. All objects that have multiple copies I placed in a single copy. For example, windows, handles on kitchen drawers, furniture and fencing sections. I did this because it's much more efficient for performance to duplicate objects in Unreal Engine. In this case, they will have a much smaller number of draw calls. At the same time, draw calls affect the performance of the scene and the number of FPS in Unreal Engine. Each real-time frame has a cost to the system and it's measured in milliseconds. The higher the cost per frame, the lower the FPS. Let's look at a simple example of how geometry affects the number of draw calls. Empty scene. Let's look at the statistics. 151 draws. I will take this value as the starting point. Now let's look at the sofa asset, which consists of individual static mesh elements. The number of draws has increased to 227. Minus 151 of clean scene results 76 draws are needed for this asset. Now the same sofa but as a single static mesh actor. 184 draws minus clean scene is equal 43 draws, which is 33% less and more efficient. Now 25 instance copies of static mesh actors, which is equal 153 draws. Next example, 25 instance static mesh actors combined into a single actor using actor merging. There are 39 draws in total, which is even less than just one static mesh actor. As you can see, this is one of the most efficient way to duplicate static mesh actors in a scene. Draw calls is an important, but not the only factor influencing project performance. With stat GPU cancel command, you can get statistic about which processes make the average frame rendering time. Let's go back to the project. After I finished preparing the scene, I exported it to Unreal Engine using the Datasmith plugin. To set up natural light, I use the Sun Sky system. For the sky, I used an HDRI texture. I created a material and then applied it to the sky dome mesh. Sky dome mesh you can find in the content of the engine. After adjusting, the light in the exterior looks great. Which I can't say about the interior. You can see multiple light artifacts. To improve the light, you need to understand how geometry coverage works with the Lumen Surface Cache. First, I need to activate Surface Cache View mode. Areas that don't have surface cache coverage are colored pink. These areas will not bounce light. The appearance of areas not covered by the surface cache is due to the fact that I merged the geometry of the house into a single complex mesh. There are two ways to solve this problem. The first is to increase the amount of max Lumen mesh cards in the asset editor. But in my case, it didn't solve the problem. The second way is to break a complex mesh into several simple fragments. This is an effective way and it helped me fix the uncovered areas. In the next step, I configured the post-process volume separately for the interior and exterior. This allowed me adjust different exposure settings, light quality and different color correction. To fine-tune the light, I use the display mode Detail Lighting. Let's compare the results before and after adjusting. Now the light looks much better. Light artifacts remained in some part of the scene. To understand how to fix them, you need to activate the Lumen Scene mode. In this mode you can see how Lumen works. In this mode it's clearly seen that there are rays of light on the wall that passes through the ceiling. When I move in, it flickers, which leads to appearance of artifacts. The same problem here. This problem is caused by directional light. You can solve this problem with the help of additional geometry that will block the light rays. I created cube shapes using standard primitives of the engine. This may work in some cases. But as for me, for example here, it doesn't work. The light continues to pass even through the new geometry. For me, the solution was to choose a different position of the sun, at which the artifacts would disappear. To set up materials, I used Megascans presets. This is a quick way to set up materials as the presets have all the necessary pre-configured parameters. To create the grass, I first wanted to use the static mesh assets from Megascans. But for interactive visualization, stability and performance are critical. So I decided to use grass procedural material. I made this material with the parallax occlusion mapping. It turned out to be a great solution for LAN. Material showed excellent performance. To create the environment, I used Megascans assets. Now the library contains assets for almost any purpose. Let's look at artificial light. When you are working with dynamic lights, you need to take into account that they affect the performance of the project. Therefore, I used it in limited quantities, mostly point light, since this type of light source is the most efficient. With point light, I illuminated large areas of the scene, such as the area near the fireplace or the entire room, such as the bathroom. I also use spotlight along with IES to get the light profile I need. Important setting to performance for each light source is the attenuation radius. I set it up for each light source separately. Also, you need to avoid close placement of light sources so that they do not intersect. For exterior lighting, I also used point light. To improve performance for all landscape lights, I disable shadows. This did not affect the visual perception, but had a positive effect on the FPS. To highlight the facade, I use spotlight, where I also deactivated the shadows. With the help of levels and blueprint, I divided the scene into two parts. The first part is the exterior and the second part is the interior. When the user is outside the house, levels with interior objects and lights are not loaded into the scene and do not affect performance. As soon the user gets inside the house, the interior levels are loaded and the exterior levels are unloaded at the same time. This decision helped me reach my target FPS of 60 frames. I also attached a change in the position of the sun in this script. I needed different settings for the position of the sun so that the light hit the room at the right angle and didn't create artifacts. To run this script, I used geometry that fills the interior of the house. It is a trigger that starts script when the user crosses it. To hide the process of transition between levels, I created a preload screen. The length of time the screen appears depends on the system on which the project is running. This means until all levels are loaded into the screen, the loading screen will be displayed to the user. Now let's look at the furniture replacement option script. Here is its structure. Since I have several different sets of furniture in the scene, I need the replace functions to be activated only when the user approaches one of the objects, because the replace action is bound to a single E key. For each of the objects I created a collision. When the user crosses it, an interaction label widget appears and the object replacement feature is activated. This is a good solution for separating different functions assigned to one key. Now let's look at the main menu. I made it as simple as possible with the pre-configured graphics options, in order not to distract the user with unnecessary options. I also created some other features using the blueprint, such as automatic opening and closing of the doors, zoom and high-resolution screenshot. Then I created cinematic animation for the presentation of the project. I animated the cameras with level sequence. For each camera, I separately adjusted the exposure and focal length to focus the viewer's attention on the desired part of the project. Video editing I did in DaVinci Resolve. If you liked what you saw, make sure to subscribe my channel for more useful content. So, let's look at the final result.